having us again this year. Last year we presented a talk in this same room, and we're really happy to share this new story with you. So the story I'm going to tell with my colleagues here is how we switch from a Mysql database to a Graph database, namely Neo4j, in the context of an inquiry, so it's science, trying to do some new philosophical theories. Yeah. And so basically our talk will be a story about how we did a long refactoring process. Sorry to introduce my colleagues, Guillaume Plic over there. We both are in the Media Lab Sciences Po research lab. And then Guido worked with us for a long time and then switched to Luxembourg in the DH lab in the CVCE. So, Bruno Latour is our scientific director of our research lab. He is basically French philosopher. You could tag him with philosophy, anthropology, and sociology of science. He is famous for having developing one theory with some colleagues of him, called actor network theory. So, if you see in this talk some concepts that can be related to this theory framework, I'm really interested to hear you about that. I'm not sure we try to get inspired by this theory. But I would like to thank Europe. We spent some money from Europe through the ERC that Bruno Latour won a few years ago. So thank you, Europe, for featuring us today. So the intellectual project, the research project we participated in, is called an inquiry into modes of existence. We call it AIM. If I have to sum it up in one sentence, and I will not tell more about this in this room, it's an anthropological inquiry. So it's like an anthropologist who will not have a look into some cultures in Amazonian forest or in, I don't know, places in the world. It's actually an anthropologist who looks at what we call the modern society. And he tries to describe, from the anthropological point of view, what does modern means. If you want to know more about that, you have one link here to a recent publication our colleagues in the project published recently in a design review. And if you want to learn more than that, there's a book you can buy, paper book. It's in French here, but it's also available in English, in German, in lots of different languages. And this book about philosophy has one very particularity, which is that you will not find any footnotes nor glossary inside, which is something kind of weird in the humanities. The project started with a book published, and then we organized a series of workshops to discuss with other social scientists or the philosophical points made by the author of the book. Just a picture of an example made in 2014 in London. And I do think that the talk we do now is part of this series of workshops. And basically what we add to this project on our site is that we developed a web platform. You can access to this through this URL. Looks like that. And in this web platform, you can learn more about the project, of course, and then you can access the book that you can see. And if you do so, this is what you're going to experience. So you have three columns. On the left side, you have the book. You can read. It's the exact copy of what you have in the paper. You can read it. You can find links to vocabulary. You can read, of course. And then you also have links to documents, which you don't find in the book. And so documents can be multimedia, like slides of pictures. But you can also go back to the vocabulary and explore this vocabulary, then you reverse the symmetry, and you can find all parts of the book that cites this precise vocabulary. And you can go back to the book and go on with your reading experience. Right. So, what do we have as data model? to support such an web experience. So we have three columns, we have three kinds of objects: text, the book, voc, vocabulary items, and doc, documents. They all share a structure of a hierarchy of contents: chapter, containing subchapters, containing paragraphs for the text, voc item containing paragraphs for the voc, and documents, which contains paragraphs, slides, and multimedia resources like PDF, pictures, video, links. And so, as you've seen in the previous slide, actually we also have links. We can add to one particular paragraph in the book an anchor that says that this particular phrase, sentence, talk about this vocabulary item. You can do also links from the vocabulary to a document, or from a paragraph in the book to another document. So we have hierarchies and links. Okay, so let's try to describe the Mysql domain, model we used in production. Translation. Okay, so we had, I simplified the schema here. I just focused on the items I talked about before. We have users and other kind of stuff like uploading media and table like that. I just focused on those three, and a fourth one. Go. Book item. So how do we put the hierarchy of contents into one single Mysql database? We use a tree where actually every content has an ID, of course. So a paragraph, it's the smallest one, has an ID, and then you have three important fields, which are root, left, and right. With a root, left, and right, and an ID, you build a tree of content. And we use the same structure for the three items. Root, right, top. Now, what about the links? The links are all stored into one table called link, in which you will find information about which paragraph is citing which items. To implement that, we have this model. The links lines are dashed because they are not exactly what we can call a Mysql constraint foreign key, because if you look at the beginning of the table fields, you find an ID. Okay? You have a from ID and a from root, but you also have a from model. This variable indicates which table to target when trying to retrieve the ID and the root. This is for the incoming. And from the outgoing, we have two ID, two root, and two model. I don't say this is what people should do. This is what we've done. Okay, now, in a train coming to Brussels, I said, what if I was even recrafting the query in SQL that will produce the content of the book from the Mysql and the schema I showed you. This is what I ended up with. Basically, with this query and with three joins, I can have a CSV with chapter column, subchapter column, paragraphs, and links, stored as a multi-valued in one cell. I don't know if you like as well. This way. Yeah, of course. I use PHP mainly to start this very tool for okay, and just to for you to understand the context, in production we have this Mysql database, but that one was wrapped into a PHP framework server. And we are not really in on PHP. So I told about the Mysql database, but actually we had more. We also had a Solr index, because we wanted to implement full text search. We had a Mongo database, because at some point we wanted to add a new web interface to the same data with a new developer. He couldn't bear using PHP Mysql, so he did, let's say, a new project connected to the same data, but using Node.js and Mongo. And, oh yeah, we have another MongoDB wrapped into a Python twisting server for handling bibliographic references. And we have a SQLite database for the blog, because the blog was has been implemented through the Ghost software. Actually, we forked Ghost because that was wrong, and it works. Still works. Mainly, well, as we can. And the Microsoft Access that no, that's a joke. I don't have this project, but actually I have one in another project. But I might tell this story later this year in July in another conferences. In I hope if my paper is accepted in DH 2016. Okay. Sum up the stack. So this is what we had at some point in production, and we had some extra money to say like, let's do something a bit easier to maintain, right? So this was the plan. But to explain it better, I'm going to broadcast. Do I have sound here? I can do without the sound if you like.
Try it.
Okay. We'll see if it works. So I had to explain our plan de facto as a lead dev to our product owner, who is actually the scientific director, Bruno Latour. And this is the video our project manager took when I explained that. Okay, no sound, but you can read it in English. Medium. Neo4j, you got it. Yeah. And we need an admin. So, we had Mysql, we had this context, and we thought about Neo4j because we thought about it for some time. We started in 2011. We had to build a web crawler, and we were hesitating between a solution in Java, pure Lucene, and a Neo4j. I asked the guy I hired to make a comparison between the two, but he couldn't do it, so we did a pure Lucene. Then in spring 2012, at the beginning of the project, I wanted a developer to test the Neo4j. Couldn't do it, not with the skills to do it, so we switched to Mysql. And then in summer 2012, the first intern experimented it. Then in summer 2013, the new intern, Guillaume, tried it. And then finally, in fall 2014, yeah, let's implement pain in Neo4j. That's where the second part of the story starts. Here.
Okay, so now we used to have multiple databases, and now we're going to use only one to rule them all, which is a Neo4j database. So, several thousand lines of code later, to switch the ancient data model into the newest one, we have Neo4j. So, Neo4j is a graph database, but I think you are all fairly acquainted to it. This means that you don't store tables, you create nodes, you create edges, etc., etc. So you store your data as a graph. So, knowing the ultra-relational nature of our data, it was kind of a fit. So let's try and see if we can do it. So migrating. So how do we go from the scrappy MySQL schema to the new one that could better fit our new database? Okay, so this is now actually the schema that we have in Neo4j after the old one. So you must remember the old one in MySQL. So now we have books, which have a series of chapters, which have a series of subheadings, which have a series of paragraphs. And then you've got vocabularies, you also have paragraphs. You've got documents who have slides that can have media or paragraph, and those media can be referenced. So this is basically the new model. It's a bit simpler, it works, and actually the real model is more like that, but we will skip because it's not really interesting here. So, what kind of problems and what kind of choices did we make while migrating the data? So, I will speak here about only 3 things. So, first, how do we handle a series of ordered links in Neo4j? Because this is not actually very straightforward. So, how do you store a series of ordered links in Neo4j? The second point would be how there are some specificities of the Mysql data now not relevant in a new data model, which is Neo4j and therefore a graph. And the third point would be how are we going to handle translation, because we have a version of the book in English and a version of the book in French. So how are we going to handle this in Neo4j specifically? So on the subject of ordered links. So remember, we have a book. So this book has many chapters. Those chapters have many sub-chapters, and the sub-chapters have many paragraphs. I think you will acknowledge that it's better to read the book in the order it was described in the beginning, because otherwise it don't make sense. So we have to find a way, with nodes and edges, to actually have this order in the database. So how are we going to do that? So solution number 1, we're going to make what is called continuation relationships. So the query here is Cypher, so it's the query language of Neo4j. So actually we have chapter, which is linked to the first subchapter with a link which is called starts with, and then all of the subchapters have a link to the next one by a next link, etc., etc. So the advantages here are that it feels natural. The writing to the database in this fashion is quite easy, but drawbacks are that it is quite slow to read, and it is quite strange to recompose because we are going to use unbound queries, which are actually recursively grasping of the data we need, so it might get a bit slow. So therefore we have the second solution that we are going to use in the book, which is relationship properties. So in a graph database, you can attach arbitrary properties to your edges, and so we are going to tell, okay, this edges is actually the first one, and this other edge is actually the second one. So we are going to build our edges like this, and so with a simple query, we are going to recompose the order of the list afterwards. So the advantages here is that it's quite easy to read and recompute. The drawbacks is that it may get very costly if you want to write a database, because you might get in bad use case where you have to rewrite all the links to match the new order. Okay, so actually we chose the second one for reasons. So we only found 2 main solutions, but there might get other solutions. The thing is, some people even say that maintaining ordered links in a graph database is kind of an heresy, but we have a book and we cannot really do otherwise. So let's handle the heresy. And so if you have other solutions, we'll be very glad to hear about it. So now we have to come back to the documents. So the documents in the book are organized thusly. So you have one document which has many slides, and those many slides have many elements, which can be media or text paragraph. So the idea is, should the slide node still relevant? Is the slide node still relevant in our new data model? The thing is, at the beginning, the slide was a design principle, which was dropped later on other interfaces, and which was mainly an obligation made by the Mysql database. So do we need to conserve it? So we have many solutions. So is this an artifact and should we drop it? So should the document be only a list of elements? Or even should we grasp all the presentation of the node and keep it into Markdown and put it as a property of the node, and then just link to the relevant part of data we need to link? So actually we did not choose to drop the slide because of legacy purposes, but the question remains. So this is the kind of question you are going to to handle when you try to pass from a data method to another one. So the third question, how are we going to handle translation? In the original Mysql database, you had one row per paragraph, and one property was the French version, and one property was the English version. So the problem here is that you are going to really tightly bind those two versions, and if you want the two versions to drift apart and become arbitrarily different, you are going to have issues. So what we did here is not not store the properties in the node himself, but split in two nodes. So one node is actually the French paragraph, one other node is actually the English paragraph, and they are linked by a translation link. So then we can drift apart, and so we can add a new translation very easily because we don't have to add properties to nodes, and we can make different versions of the book very easily. So this is the third point we tackled. So now that we know approximately what you need to do, so we are going to migrate. So how do you monitor this migration? Because the process is quite hard, and what you want to ensure is to do so comfortably, because this is very awkward to do so, and ensure that no data is lost within the process, because you don't want obviously to lose data. So therefore, we need the properties to help us achieve this objective. So on the legacy side, it's quite easy. Okay, we have PHP, Mysql, it's quite legacy now, so you've got huge and very useful tools such as PHP-MyAdmin, RoboMongo, etc. It's quite straightforward. However, monitoring a graph database, which is quite a recent concept, is another problem altogether. So how are we going to monitor the data in the graph database? So the obvious solution is to use the Neo4j Admin. So I'm not sure if one of you are acquainted with the admin, but it's a very good tool. It has very good UX, so it's very easy to handle, etc. It's very handy to provide, explain your queries, have a sense of what they are going to return, etc. And they can give a fine sense of the local geography of a node, but only the local geography of the node, and this is very important. So, there is a problem. Neo4j Admin is a very fine tool, but it cannot display large graphs, and obviously the book is a very large graph, so how can you grasp the totality, the whole of your graph? And it only has a basic string layout, which won't handle correctly the complexity of our whole database. So the problem in the end is that we cannot use visual network analysis on our data. Thing is, in the laboratory, we use visual network analysis on a daily basis to handle several problems. So why shouldn't we use this tool to handle such things as a migration? So what is visual network analysis? Graph as an object are very complex things. It's a very symbol of complexity. And the thing is, humans handle this complexity very badly because it overcomes our cognition capacity. So we cannot handle this complexity easily. So what are we going to do is we are going to visualize this complexity. We are going to use data visualization tools, and we are going to perform a visual analysis of this graph and trying to understand some things about it and its geography, which can help us in the process. So to do so, we designed a very proof of concept tool, which is called Agent Smith. It's a proof of concept. The idea is to be able to apply this visual analysis on large graphs, and on large graphs coming from Cypher queries or Neo4j database. So it aims at being a complementary tool to the admin, not a concurrent one. So it's obviously a matrix plan about Agent Smith, Mr. Anderson. And so how are we going to handle rendering? So SVG, which is used by the admin, is a very useful tool if you need to easily customize or draw graphs the way you need. The thing is very less performant than other techniques. So here we are going to try to use Canvas, WebGL, etc. So we are going to use a library which is called Sigma.js to handle large graphs. On the layout side, so a layout is a way to properly specialize the node of the graph. So the thing is that this Spring layout is more cosmetic than really accurate. The thing is, its goal is only to ensure a naive and tight collision of the nodes and to display them evenly in the board and to be able to handle the small graphs. So for our use case, we're going to use FOSDEM plus 2, which is a layout algorithm developed by someone who is just here in the room. And we're going to give more meaning to the graph geography and understand our graph. So I'm completely aware that it is a bit blurry, so I'm going to try and show you a very specific example to see how we can use this tool to spot inconsistencies in the data. So first use case, we are going to find duplicates in the base. So this is actually a tool. So I'm going to type in a query whose goal is to retrieve documents in the database who has only one slide and whose slide has only one item, which is a reference to a bibliographic text. So I'm going to run the query, and here I've got a graph, which is a bit specific. So you've got a lot of components everywhere, and you should notice that there is a clear pattern. So let's zoom a bit. Here we've got a reference. This is a slide. This is a document. So why do we have two stems? It's because we have the French version of the document and the English version of the document. So normally we should only have those patterns in the whole graph. The thing is, you should quickly notice that it's not the case. We have this strange starry thing, and if we zoom a bit, we will discover why. So this is actually a reference to some text, and here we've got the English document, here we've got the French document, and here we've got the English document again, and here we've got the French document again. So we just discovered and explored duplicates in the database by visualizing the graph we just made. So one duplicate, two duplicates, and there should be a third one somewhere here. Okay, so this is the first example of how we can use visual network analysis to spot inconsistencies in the data. So now we're okay. So this example is a bit more tricky. So we are going to do a different query. Let's assume the book has a list of specific themes it explores, and of course those themes are linked to paragraph of the books, documents, images, etc., etc. So let's draw the graph of those themes here. So let's do it. Okay. So let's zoom over here. Stay here. Okay. Unfortunately, the colors are a bit shady. So this is actually a mode. So treat it as a theme, which is the political theme of the inquiry. And here, for instance, you have a little balloon which is composed of documents, paragraphs, etc., which are linked to the theme. Here you might not see it clearly, but there are other nodes here, which are greens, which are documents specifically. So we have to come back on the what does a layout algorithm do. The idea of a layout algorithm is to put nodes which are highly linked close together in a 2D representation. So what we are learning here is that those documents are more linked to the mode than they should, because actually there should be only one balloon of data. So this means this document is more linked to the mode than this. This is not consistent because there can only exist one link between an entity and the theme. So what went wrong? Actually, I linked twice the French document to the theme because I fucked up in my node matching. So we're going to fix this. So this is actually the curve before. You have to look at the line 388, and we're going to fix it. Okay. So before, after. So I just spotted an inconsistency in the data, and I was able to fix it by analyzing the graph and spotting where the problem was. So here is for the second example.
Okay, to sum up this part, so now we have an Neo4j, we have data init, we made sure the data were consistent thanks to visual network analysis, and now we can do the same query I made with Mysql at the beginning of the talk, with the cipher. This is what it looks like. And also to sum up with a new stack. So this is to be compared with the first schema with all the arrows. So now we just have the famous blog here with the SQLite still here. The Mongo in Python is still there, bibliographic references. And all of the rest is only one Neo4j, one JS Express server, and 3 different HTML5 interfaces that use the same API. The 3 ones are the book interfaces you've seen at the beginning of the talk, another one that I didn't talk about, and the admin, the way to edit data. We will not talk much about that. So now, let's give the mic to Daniele, who would explain us how he used Agent Smith and Neo4j for another research project.
So, finally, 1 year ago, I left the Media Lab crew and I joined another team that is the team in Luxembourg, the CDCE. But then I bring with me all the experience we accumulated, especially this Agent Meet that we were just developing at that time, and the Neo4j. Especially because the shift was a sort of a big shift for me, not only because of the city were far and distant, but also because we shift from philosophy to history. So I had to work with historians, and my task, my job was to develop a web application that could handle and could help people to explore the connection between the documents that this center, which is a research center on the European integration process, store in their archive. So basically they have a huge collection of pictures and documents that deals with people from the Second World War on who try to build up the European Union. And moreover, this is one part of the task. The second part was there is already an existing workflow, and the task was to merge these two needs. So from one side there is the need for exploring the possible connection, and the other one was to refine the data creation process, so how the metadata are attached to these documents. And finally, one last, which is our ongoing task, is how to publish effectively this connection, how to make it visible. So the idea was to use, of course, at the very beginning, at least, in order to explore this complex universe, was to use Agent Smith and Neo4j. What I did for the I'm interested also in text analysis, among other things. And then I used this Django Idle, which is an entity disambiguation tool made by Max Planck Institute, that basically takes a text, and from a text it extracts some key elements like location or persons, or some entities that appear in Wikipedia. And basically what I wanted to do was to display this richness, so this possible connection, and also to monitor this analysis that was ongoing. We had more than 18,000 documents, so we could lead to errors like we saw before. So then basically the structure I use is far simpler than AIM. We have one document on the left, one document on the right. They are both interview, and they're both connected because there is an entity that appears in both documents. So it's very basic. And you can see there is a follower that appears in both, and it could be linked to other two entities that are underlined. So basically, I start putting everything in Neo4j. The brown nodes are the documents, and the blue nodes are the person, in this case. The brown documents are vectors, because we have collected a lot of vectors exchanged between some key actors. And finally, what I discovered that this tool can also be used for data curation, because Okay, this is for later. But then there are also different overview on this collection based on which kind of relation do we have. These are persons that occurs in pictures, like in the caption and in the title that people on the road. But then we can find them, which are the main topics. So for the exploration part, we can also have an overview. Yeah, zoom. But what was important is that this corpus is multilingual. So as aim, we have two different languages, more than that indeed. We have till 5 or 6 translations for one document. And what I did, I ran this ambiguation process in parallel for French and for English in order to spot the best candidate for the person that should link the two documents. So basically, I used then Agent Smith also to spot which are the persons that are not here in the two languages. So I assumed that the translation were correct, they were complete enough. And then what was interesting enough is that by using this difference in languages and visualizing it in with this layout, with this specific layout, we can spot really very subtle errors like Robert Schumann, which is a person, the blue node, but then it's not a person. So this graph is this graph of errors, and it could also help us during the data curation process. Same things here, the symmetry that we saw in we can see in the layout can help us also in disambiguating these people. So if we have a huge archive, a huge collection, this visualization could be also a nice tool to curate this archive. So basically, this is the question that I'm like after a year that I'm still wondering. Are this kind of visualization, the graph visualization, useful for a fast data creation process? So by visualizing patterns of errors, patterns of mistakes, can we help them in reassemble and show the real complexity of the system without all the noise? Well, we have these three. We can spot asymmetry, we can spot well-placed false positive because of the degree, so we can spot errors that are in this collection. But also Neo4j provides us with a full-text listing search that is really, really useful, especially if you want to spot for errors, to check if what you've done is correct enough. So basically, for annotation error in the layout, we can see if there are some person which are not person, so the disambiguation method is not accurate enough, but it's not a problem because then we can just spot it. And within this tool, which is an admin tool, we can correct automatically the error. Or we have, like in this case, the false positives. We have persons that again appear together, and we have a sort of patterns of error. So there is something strange that is happening in these three documents indeed. But then the graphs that I provided were not refined enough. Okay, sorry. And then I used Neo4j to build up monopartite projections. So before we had resource to entity links, and now we wanted to have only entity to entity because the idea is to find connection between these people. So basically, I calculate the Jackson similarity between the person in this case, and we end up with this kind of network. And then other question arose, because what does this relationship mean? Like historians, I was working with this researcher, they told me that it's not normal that we have these two people that appear close. What does it mean, really, a relationship? And then I think about that this kind of tool can also help the researcher that is not a specialist to work with this kind of technology, because then we can just decide visually which are the relationships that are needed or not. So we start thinking about, okay, we can transform the relationship between person to person if they appear in the same picture or if they appear in the same letters, for example. So it was everything was one sort of negotiation with the researcher, but it was nice because everything was open up. This is important because within this layout, within this graph visualization, what we open up